Okay, guys, so I think we can move further. Just a second. Yeah. So compute percentages. Again, as what we did during the first session in the class. I mean, you remember how to calculate these percentages. So to calculate row percentages, you just have to find the summing number of each cell in a row. So in our case, this is 5. Let me again add annotations. This is 5. This is a summing number, so this is a resulting number for first row. So for the second row, which is the summing number is 13. It's 11 plus 2. So, and in order to find these percentages, we just find first with ratios. We just find these ratios. Right? Yeah, so we find these ratios. And afterward, by multiplying it by 100, so we got finally percentages. So very straightforward way to solve this exercise. So I don't think that you face any problem solving it. So for task number C, for C point, so you had to compute column percentages. So the same way you do this. So the same way you do this, so you just calculate the summing number of each column. So you just sum each cell in a column, and you get with numbers, with resulting numbers: 18, 12, 30. So this is a sum of with numbers. And afterward, by finding it, so you just again find with ratios, and by multiplying it by 100, you get these percentages. So again, and by doing this, we can see the frequency of popping up with pairs like A1, A2, B1, B2, C1, C2 by columns. So we can see how frequently, for example, the variable y equal to 1. What's the frequency across each category? So, and yeah, so this is what C point, and that D point, so you need to answer the question, what is the relation, if any, between X and Y? Yeah, so you just have to describe these two tables, like this table and this table, and you just have to highlight some striking facts. For example, like R values are all in Y equal to 1, B values, yes. So it just describe results you got. I mean, that's it. I mean, nothing more. And also, it's up to you. So it's you can express your thoughts in different ways. Really, you are not constrained in this way. So just let us know that you understand what you get. So it was for exercise 1, so it was pretty easy. So for question 2, the task you can see on your screen. So here we deal with hotels with rate per night in dollars, or with cities. So we can go to exercises. So in this exercise D, okay. Yes, so just So let me see the chat. And can you tell me what exactly you don't understand? I mean, here you just have to describe with tables, and I mean, so look, for example, when we calculated with row percentages, we get the next result. So you see, for example, like 100% of observations for A are for value y is equal to 1. So it means like the chance that the observation for variable x, which is A, can pop up only if the variable y is equal to 1. Is the same we can do for the next. Let me again use annotations. Yeah, the same we can do for the B. So we see that most probably we will see that the variable with variable x with value b will pop up for variable y equal to 1, and only for C. And only for C we can for C we can expect that it appears more frequently for variable y, which is equal to 2. So actually, it's not very how to say meaningful exercise because here we don't know what is x, what is y, what are these variables, and then we just look at these percentages and just really state what we see. The same we can do, for example, when we consider these variables for y. So we see, for example, that that most probably most frequent pair is B1. So it means like most probably for variable y, the value 1 appears for pairs B, for pairs with B. And just again, let me add annotation. So this is the most frequent pair, like you see B1. So for y is equal to 2, so this is the most frequent pair. C2. Yeah. So frankly, nothing more. I mean, you just have to describe like the frequencies of these pairs in this table. And so sorry. Any other questions regarding first exercise? I don't know how to explain it better because really you just have to describe with frequency. That's it. And I mean I cannot see the chat. How can I see the chat? Okay. Okay, now I see the chat. Okay, now it's clear. Okay, so we can continue. Okay, sorry guys, it's also the first time when I use this WebEx, so sometimes with interruptions can happen. So because actually I wasn't sure that I can see our chat. So okay, then let us start with the question number 2. So let's go to exercises. So for with exercise, we have to find the mean and the median, mode, and quantile. So I think in the lecture you have all formulas how to calculate it, and actually let's do it. So yeah. So here's the way how we calculate the mean. So we just sum up the variable of interest, in this case with a rate per night. So we sum up it across all entities in our table, across all elements. In this case, the elements which are cited. And we just first we have to find the total number. So this is the sum of all three rates. And we know that in total we have 12 observations. So we just sum them up, and so we sum up and divide by the total number of observations, and we get this number. So pretty straightforward. I mean, yeah, the average hotel room rate is 159 per night. Bags per night, yeah. So the next, what's the median of the hotel room rate? So, and on the next slide, you just see some definitions for the median. So the median is the value which separates our data set into two halves. Yeah, and also, I mean, the important point here, yes, so you have to bear it in mind that to do so, to find the median, this way you have to have your observations in ascending or descending order. So your data should be strictly ordered. So it's not gonna be like a random distribution of your data. So before start doing with exercise, you have to be sure that your data is organized in the proper way. So you have to ascend it or descend it. Also, you know that by itself the median width is a second quartile, and also it can be considered as the tips percentile when the data is divided into 100 equal parts, etc. So I think all definitions you can find in your lectures. Yeah, and also it's important to understand, also I have to pay your attention here that to calculate the median, one must be aware of the total number of observations is odd or even. So depends on it whether the number of observations is odd or even. We should find the position, to find the position of this median element differently. And I will show you if you will have also some further questions. Yeah. So, and here, like, if n is odd number, so the value in the middle, so you just have to find this position. So actually, if n is an odd number, so the median is just yes, so you just have to calculate it this way. It's around, so we just have to round it. I hope you see it. Yeah, it's like n divided by 2. And median in this case should be x with subscript y. So this is for this case. If we have the even number, so we find this position differently. So in order to find these middle values, so we have to find first the position of these two middle values. Okay, I think I will show you further with numbers. I mean, not to, yeah. Okay, because again, I will come back to it. Yeah, just let me start. Yeah, right here. Yeah, right here I can show you better. Just let me again add the annotations. So you see how we search for media. So we have 20 observations, right? So which is an even number. So it means that we have to find the position of with elements and how we look for it. So actually, again, first step, you just have to find with first A. So which is just a round number. So you just have to round it. It's n, big N divided by 2. So in this case, y is equal to 10. So the first element is 10. So you just calculate. You just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we found the first element, and the next element is yes, round up. I mean, round according to usual rules. What do you mean? You mean it'd be just yes, it's just usual algebraic rule. So, for example, if you would have here, for example, yes, exactly, yes, Dylan, yes, we do it like this. But since we divide by 2, we will have numbers only with which ends up with 5. I mean, with 0, 5. And by rule of rounding, I mean it all the time goes to the bigger number. So 0.5 goes to 1, 1.5 goes to 2. Yeah. So since in order to find median, so we have to divide the number of our observations by 2, so it goes like this. So just let me delete it. I mean, not to confuse you. So let me continue. So yeah. So and we are looking for the next element. Just the next element should be y plus 1, so it should be 11. So, and in this case, we calculate for even number the median as xy x plus 1 divided by 2. So in this case, so this is the way how we found with middle values. So yeah, and actually, yeah, this is it. This is our median. So this is the way how we find with middle positions for data sets in which the even number of elements contained. Yeah, and I hope it's more or less clear. Okay. What's the mode? A mode is the value with the highest frequency. The mode here is 167. Also, just let me show you my R script. I hope maybe it will be more intuitive for you. Just let me share with you my R studio. Just a second. Yeah, just a second. And I will show you what I actually want. So this is the second exercise. So, and in order to calculate, so you see my R. So in order to calculate the mode, we just need to create with histogram of our observations, and if we take a look at this, so you see like with observations appears twice, while others appears only once. So, and since it's the most frequent observation in our data set, so we have to find it. We have to find the observation which appears twice in our data set. So which is like the intuition which is behind the whole exercise. So stop annotating. Okay, let me go back. Yeah, so for example, just use this table here. So you see, like for New Orleans and for San Francisco, we have the same rate per night, and obviously with a shift. So we were looking for width. So and that's you have some answers here. So the mode 167. So because it appears twice in our data set. So, what is the first and third quartile? Okay, I think maybe it was one of the most difficult exercises for you, because actually it seems a bit tricky how to calculate it. So, so how to find width positions? Okay, let me use annotations. So just a few slides ago, we found like the median. So the median, so we found width positions. So you already know how to find width positions. And as you also know from the definition of median, so which is the second quartile or the fifth percentile. So we already found it in the previous step. So the next thing to do, so we have to find how to find width position. Actually, I would advise you to do the next. Okay. So in order not to have a mess, let me delete my annotations first. Okay. So first you have to divide your data set into two parts, into two chunks. So I would advise you to do the following. So first you have 20 observations. So you divide it. So you have it in ascending order. So here you see like so your data is properly organized. So it's ordered, perfect. So we can deal with that. So after the next step is divide after finding the median. So you divide your data set into two chunks. Obviously, each chunk consists of 10 observations. Yeah, and afterward, so actually the first quartile, so the first quartile, which is the median for the lowest value, for the data chunk with the lowest value, with the low values. So we actually, in order to find first quartile next, so we have to find the median for with data. So which is the median for with data set. And in order to find the third quartile, which is just the median for the data set with highest value. So and let's find it. I will just show you how, for example, how to find it for data chunk with low numbers. So here, so we have 10. So 10 is even number, right? So I'm working only with with the lowest value. Okay, so it's even. First, we have to determine that it's even. So it means that we have to. So we find y as 5, and y plus 1 is equal to 6. So again, 1, 2, 3, 1, 2, 3, 4, 5, 5, 6, and so we find the median for with data set as again xy plus xy plus 1 divided by 2, and you see, so I will use the subscript low. Yeah, just like the median for the low chunk, and this is here. And the same procedure we do for the data set with the highest number. So let me use different colors. So, and by just again, since with data chunk consists of the same number of elements, so with y and y plus 1 would be the same. So here it's 1, 2, 3, 4, 5, and 6. And again, you see, this is the way how we calculate the third quartile. So, and actually, by calculating width, so we can find all quartiles. So, and fourth and zero quartile is just the zero quartile. Okay, let me get rid of all annotations. So this is a zero quartile. Okay, you got me, guys, I hope. Yeah, so, and this is the way how we can calculate. Also, I think you can use the formulas which you were given in the lecture. But this is the number in the data is what, how do we split it? Again, yes. Okay, perfect. Good question. I mean, if you have the odd number of observation in your original data, so you have right. You remember how we find the position for median. So which is just, for example, if okay, just let me. If we have, for example, 21 observations, right? So it means like just that the position of our median element is 11. So the median is equal 11th observation in our data set. And it means like if in case of 21 observations, so we have the median observation and we have 10 observation above and 10 observation below. So, and in this case, so this is the way how we divide our data set. So we just omit with median observation, and we have two equally sized chunks of data. So, for example, I don't know. Let me, for example, to add here. Let it be, I don't know which city, like city. CTN. So, and here, for example, with CTN, we have 21 observers. Okay. Yeah. Okay, perfect. And just in this case, we would omit Seattle, and we have here 10, 10, and 1. Yeah, you see. So this is the way. Thank you very much for your questions. So thank you guys that you stay active, and yes, any questions are welcome. So, yeah, okay. So actually it was the last point. So question 3. I think it's pretty the same. It's quite the same. So the question 3, so the task you can see on the screen. And actually again, so what we should do. So we should find mean, median, mode. Okay, we already done it. First and third quartile, and also you have to describe the data. So just, I think I will not spend too much time on this exercise. So in case of questions, that just let me know through the chat that you have questions. So here's the mean. So the way how we find the mean. So here's like 10. Sorry. So here we have 10 observations. We find the sum, we divide the sum by the number of observations, we get the mean. So also we use the technique I've showed you how to find the median here. So since it's 10, we just divide 10 by 2, which is 5, and the next element y plus 1 is 6. So the median is just an average of these two elements. And since all observations appear, each observation appears in our data set once, so we don't have a mode because they are all equally, equally frequent appearing in our data set. So for counting measure, the same exercise. So only with the difference that now we have 16 observations. So the same. The first and third quartile for marketing major. Yeah. So here. So for example, yes, here was okay. Here I will spend a bit more time. So because here, like the question what Dylan asked us. I know, okay, which is actually the same. But yes, there is a problem that here, for example, in these chunks, when we divide it, so here, like with median of initial, so the second quartile, and so initial data set consists of 10 elements. So we find the median this way, but when we divide it into with two chunks of data with highest and lowest values, so we have like 5 observations here and 5 observations here. That's why we calculate the median of these chunks differently. So since here it's an odd number, so the position of element, in this case, the position of median element is 5 divided by 2, and we have to round it. And, oops. Okay, I think I deleted with annotation, sorry. So I just, oops. Yeah, sorry guys, something went wrong. Yeah, so always chunks, just let me, 5, yeah, so just round it. So 2.5, and it goes to 3. That's why it's 3 here. So this is the way how we found it. Yes, just to pay your attention how we deal with odd numbers. That you shouldn't be afraid. It's actually all the same. Yeah. So the same exercise we repeat for accounting measures. So the same way how we find first and third quartile. And actually, yes, here you just have to compare like the mean of these two variables for accounting and for marketing measures. So you have to compare like mean, median, and quartiles. And for example, here like you see the brief summary of with comparison. So I don't think that we have to spend too much time on it because it's pretty straightforward. Because the main thing here just calculate all with descriptive statistics, mean, median, mode, quartiles, percentiles if you need, and yeah, just compare them. So I think we can go to first questions, right? So guys, just let me know if we can move further. Okay. Okay, I think we can start with the fourth exercise. So yeah, perfect timing. So so you have with 5 observations. So we have to develop a scatter diagram with X on the horizontal axis, and so actually we have to say a few words about the interdependence of these two variables, how they interrelate. And yes, sample covariance and sample correlation. Okay, let's do it. Okay, so this is a scatter diagram. So as I think you all know how to do this, so you just draw the x-axis, y-axis, and you just put all your points on this axis. And yes, so this is a scatter diagram. Also, I would like to share with you. Sorry, yeah, it's here. The fourth exercise. Just also let's show you. So actually, this is the way how we can do it in R. Also, you can use Excel, but I think with Excel, I mean, just for me, it's more convenient to use R. I mean, I just want to show you some advanced techniques for your course, but also I think you all know how to do within Excel. And also here, I just wanted to show you with graph. I mean, yeah, I just wanted to show you with scatter plot. And when we are talking about like interdependence of these two variables, so it's always good to have the best fitted straight line for our dots. So in this sense, so you can clearly see that with negative relation, so with straight line, so that there is a strict negative relation between x and y variable. And actually, also what we're gonna do further, so we want to find with correlation covariation coefficient. And actually, this is the indicator of linear dependence between these two variables. So please, guys, bear in mind, and I just want to pay your attention here to this moment. When we calculate covariance or correlation with statistical metrics for linear dependence. So, for example, if yes. Let's do it step by step. Yeah, sorry, because I go a bit ahead. Yes. Just let me return back to our so the scatter plot, easy. I mean, you can easily do with in Excel, for example. And yes, as I showed you here. So we have not like this, sorry. it's ugly. Okay, let me do it more, a bit more classy. So like with, so you see that if we feed the straight line with data, so we can observe like this is a very strong negative relation. So that's it. But for now, for you guys, for now, I mean, it's more than enough. I mean, I think maybe in the course of econometrics, you will be shown how to fit with straight line to your data. But up until now, I think that's enough. I mean, I just want to show you the logic and like the big picture behind of this exercise. What you're gonna do maybe next year. Yes, it's a bit. I think it's beneficial for you to know it in advance. So yeah, which is a scatter plot. Afterward, we have to calculate with covariance and correlation. And in order to calculate correlation, we have to find covariance and we have to find standard deviation. In order to find standard deviation of our sample, we have to find sample variance. So just also let me state it here. So like how we do it. So first we calculate variance. So when we calculate variance, we can calculate standard deviations plus we calculate covariances. And when we have when we armed with all this, so we can calculate correlation. So this is with some steps how we calculate correlation. So first we calculate variance, standard deviations, covariance, first, second, third, and fourth. So this is the way. So, and here just a reminder for you how to calculate with sample variance. And the standard deviation is just the square root of sample variance. So here you can see how to calculate covariance, and yes, how to calculate correlation. Yes, so just step by step. So like the correlation is just the covariance standardized by standard deviations of our variables. Yeah, and here's the way. So actually you also can use Excel to repeat this exercise. So first, in order to find the variances, we have to calculate with deviations from the mean. So you remember how to calculate the mean. So here in the third column, we calculate with deviation. The same we repeat for y variable. So again, we find with deviations. I also pay attention which are not quadratic deviations. And also, in order to calculate covariance, we just calculate the multiplication of these two variables with deviations from the mean for each variable for x and y. So we calculate it for each observations, we sum it up, and we find the covariance as you can see on your screen. So actually, everything you need to know for with exercise is just you have to know formulas for covariance, variance, standard deviation, and for correlation. That's it. And also, I think it's a good exercise. I think, do you want me to do it in Excel, or I think is everything clear here? I think we don't need to spend more time on this. Yeah, okay, guys. If I will see your messages in chat, I mean, I will do what you need. So this is the way how we calculated covariance. So since we already found with deviations from the mean for each variable, so we can easily find with quadratic deviations from the mean, and actually quadratic variations from the mean, the sum of these variations divided by n minus 1, where the 1 is the total amount of elements in our data set. If we divide it, so we get the sample variance, and the standard deviation of our sample is just the square root of the sample variance. So I think with the exercise, almost everything is on the slide. So the same for y variable. So and when we have all ingredients, so we found the covariance here minus 60. Actually, covariance, yeah, okay, I'll tell you about this later. Covariance, so here we have the standard deviation for x and standard deviation for y. So and we just put it all together, and we find that the correlation coefficient is the next, what we see. Okay, so and here let me say a few words about the nature of with coefficient. As I told you, covariance and the correlation coefficient, they tell us about linear dependence. Guys, please, here okay, let me use annotations, strong negative relationship. But bear in mind, please, guys, that here we're talking about linear dependence. Linear dependence. So, for example, if the dependence between x and y is quadratic, or the polynomial function of higher powers, I mean, with coefficient might be misleading. But since, as I showed you, just let me go back to R. Sorry. Yeah. Since we can see that the straight line almost perfectly fits to our data, so we can say that, okay, in this case the correlation and covariance coefficients are meaningful, because like linear relationship describes our data perfectly. But for example, here, if like the true data generating process is a polynomial, for example, like with, yeah, so I mean, so sorry for ugly drawing, but I think you can understand what I'm talking about. So in this case, if like the true relation between x and y is like this, so correlation and covariance could be misleading, because in this case it can tell us anything statistically meaningful and significant. So bear in mind that maybe I just pay too much attention to this point, but I think it's also important for you to understand for your further studies when you will have econometrics and stuff like that. I mean, you will remember my words, I hope. So here with this linear relationship. So covariance and correlation. And also, covariance is not very, by calculating covariance, we also cannot say too much about dependence, interdependence of our data. Because actually minus 60, is it a lot? Is it Is it a strong negative relation? Yes. By calculating covariance, we can say only about the sign of our dependence. So in this case, this is minus, and we can say this is a negative. But 60, you should not pay attention to with number, because actually we cannot say that 60. This is an indicator of a strong relation, of a mild relation, or almost no relation. Because what is 60? Is it too much? Is it enough? Or how to say? Is it big enough or not? For example, if it would be minus 100, minus 200, so we cannot say anything. We cannot say anything about the strength of our relation. We can say about the strength of our relation only using correlation coefficient. And this, since we know that correlation coefficient lies within the range. Within the range. I want to also show you within the range from -1 to 1, where the -1 with the perfect negative interdependence between two variables, and where the 1 is indicator of perfect positive interdependence between two variables. And since -0.9 is closer to -1, it's almost -1. So we can say about very strong negative linear interdependence between two variables. So this is it. So this is an exercise. So besides of knowing this formula, I think this is stuff you can do on your own without my help. But here I just want to pay attention that you have to understand the nature of things you calculate. So you have to understand what is raw, what is correlation, what is covariance, and what kind of information it provides you. So again, just let me recapitulate. Covariance and correlation. This is about linear interdependence between two variables. Covariance is not very meaningful in terms of determining the strength of with interdependence. Only pay attention to correlation coefficient. Only by calculating correlation coefficient we can say about the strength of this interdependence. So by calculating covariance, we can say only about the sign with dependence, whether it's negative or positive. So that's it. Okay, guys, perfect. I think we are done with exercise, and we can move further. So the question 5. I think this is almost the same exercise as we did in 4. So we have again two variables, two stock markets, S&P 500 and Dow Jones Index. So again, we have to compute mean, standard deviation, covariance, and the correlation. And yeah, and just again, in the third point, again, we want you to pay attention to the interpretation of this coefficient. So you have to understand how the mean, what's the mean, what's the standard deviation, what's the covariance, what's the correlation. So, okay, let's start. Again, so we find first deviation from the mean. Afterward, we find quadratic deviation from the mean. We sum it up. We divide it by the number of observations. We get variance. Taking the square root of it, we find standard deviation. The same we repeat for Standard & Poor's index, the same exercise. So it's when we have with deviation from the mean, we also can, for each variable, we can calculate the coefficient of covariance with indices. So again, we just multiply with two columns, we find the sum, and here we just we just find, and we divide it by the number of elements in our sample. So we get covariance, correlation again, and here you just what kind of insights you can get by calculating with statistics. So we can say, so we found like with the correlation coefficient 0.9, it's a sign of a strong positive correlation, interdependent. And I mean also we can say about we can talk about averages. We can that Dow Jones index is larger on average. That the standard deviation of Dow Jones index is also larger, and and also I think with the last point, it's not necessary point, because actually sometimes when you deal with data, it's always good to look up at the nature. I mean, what is it exactly? And here it's also, I mean, if you can Google it and you can find that Dow Jones index is using information for 30 companies, S&P, but it's also not very necessary in this case. Yeah, guys. So I think this is it. And let me know. I think we are perfect in time. And so I'm stopping it. So guys, and if you have any questions, so I'm glad to hear them. But I think we did a good job. So I think this is it for today. And yes, I'm waiting for a question. So just I can give you, for example, 5 minutes to formulate them, and we can go back to exercises which confused you, and we can repeat some steps of the solution. Yeah. While you're thinking or writing something, I just also want to tell you that actually, yes, one more time, thank you very much, guys, for joining with meeting today. So sorry, guys, for with inconveniences. It's also not very convenient for us, because I believe that it would be much better if I would see you in the class, and we can go through all with exercises together. And I mean, when you can ask me questions like in live regime. But anyway, I mean, guys, with the situation with virus, it's kind of extreme situation. Nobody expected that, and so we have to deal with it on our best. Yeah. So, but anyway, I hope it was also good for you. It was beneficial, and I could explain you how we should solve with exercises. Anyway, don't hesitate to contact me via email, so you can anytime to write any questions to me, and I will try to help you solve them. Yeah, but in general, this is it. Again, now attendance is not necessary. I mean, so I don't check your attendance, because like physically it's very hard very hard to check all of you on WebEx. Yeah, so, but I think it's, first of all, it's very beneficial for you to participate with WebEx meetings and to see how we solve with exercises, to hear my comments, yeah, and ask your questions. Yeah, but usually this is it. So thank you very much, guys. So it seems that we don't have questions. So I think we can, for today, this is enough, and we can, we can say goodbye to each other for today. Thank you very much, guys. So any feedback? Yeah, thanks. Thanks. Okay, any feedback is very welcome. Yeah, have a nice day to all of you. And yes, if you have any feedback, you can send it via email. And if you have any further questions regarding with exercises, so please don't hesitate. Yeah, see you next week. Yes, in 1 week at the same time. And I think today, yeah, I think today I will post solutions for the next seminar in order to give you sufficient amount of time to prepare with exercises, to prepare your questions. Yes. So good. Then for today, I think it was very nice. Yes, thank you, guys. Okay. So see you and stay healthy, guys. This is very hard times, and I mean, yes, I hope all of us will go through it in a good health. Yeah, take care of you and take care of your friends and relatives. Thank you very much, guys. It was a pleasure to see you. So goodbye.